Hello students, today we are going to learn about shift registers, electronic shift registers, as well as we will learn about the different type of arrangements of shift registers, means serial in, serial out shift register, serial in, parallel out, parallel in, serial out, and parallel in, parallel out. Okay, let's come to the topic. What is a shift register? See, shift register is an electronic device in which there is cascade, means serial of flip-flops are connected in electronic fashion. Okay, and shift registers are used to store multiple bits of data, means one flip flop can store one bit. So in case multiple bit of data is to be stored simultaneously at a time, then shift registers are used, and they are commonly used in processor of computer for keeping the data temporarily, keeping it and then removing it like this. Okay, so before proceeding, I will like to recap about JK master slave flip flop or simply flip flop. Okay, so which I have already demonstrated in my previous lecture. In case you want the details, then the link is over here. But right now I will take a short brief and then I will proceed. Okay, so you can see that this is a JK flip flop. Okay, and JKs are the input and Q and Q naughts are the output. Okay, so it is like this: if J is 1 and K is 0, and suppose the outputs right now are Q is 0 and Q naught is 1, in case pulse will be provided, okay, then what will happen, that Q will become equal to J and Q naught will become equal to K. As you can see, initially Q was 0, Q naught was 1. When pulse is provided, clock is provided, then Q is 1 and Q naught is 0. So we can assume this thing that data is shifting. Whatever the J and K are having, by the application of clock, the data is shifting. Similarly, in case J is 0, K is 1 and Q is 1, Q naught is 0. Now in case clock will be provided, then Q will become 0. It will mimic the value of J and Q naught will be 1. It will also mimic the value of K. So like this, Q is equals to J now, Q naught equals to K now. Okay. Again, I want to say is that when clock pulse is provided in such condition in which J and K both are invert of each other, then by the application of clock, the Q and Q naught will attain the value of J and K. Okay. Now one thing more, what is D flip flop? In D flip flop, what happens, that one of the terminal, say K, is connected by the help of a NOT gate, means whatever input is provided to J, that input is also provided to a NOT gate, and the output of NOT gate is connected to the K of the flip flop. So what will happen, in case to the J 0 is provided, automatically the K will be 1, and in case to the J 1 is provided, automatically K will be 0. And in that case, clock pulse is provided, the Q and Q naught will attain the value of J and K, means data is shifting from J to Q and K to Q naught, like this. Now let's proceed at how a shift register works. So here I am taking a case of a 4-bit shift register. So what we see, that there is cascade of 4 flip-flops. Okay, it is a 4-bit shift register in which the inputs are JK and outputs are QQ naught. You can see yellow flip-flop, purple flip-flop, red and blue. Okay. Now the output, the Q of all flip-flops are connected in serial fashion. You can see that Q of yellow flip-flop is connected to J of purple flip-flop. Similarly, Q of purple flip-flop to J of red flip-flop, like this. And all these are D flip-flops. Okay, means if J is 0, then K will be automatically 1, and if J is 1, K will be automatically 0, like this. Okay. Now here I am taking an example. Suppose a CD is there in which a code is embedded, that is 0101, like this. So when this CD spins, the sensor senses the code and sends to the J of this first flip-flop. You can see the sensor is there which is passing through an AND gate. This AND gate is just to enable the sensor to send the data. In case the right terminal of this AND gate is 1, then the data will be sent. In case it is 0, then no data will be sent, because in case one of the input terminal of AND gate is 0, then output is always 0. Okay, so when it is 1, it is enabling the sensor to send the data to the J of yellow flip-flop. Okay, now this is the clock input, and clock is applied parallelly to all the flip-flops. You can see if clock pulse comes, then it clocks all the flip-flops simultaneously. Okay, now we can see that right now the sensor is sensing 0 from the CD. Okay, and it is presented at the J of this yellow flip-flop. Okay, now in case first pulse arrives, then what will happen, the 0 of this J will transfer to the Q of this yellow flip-flop. Okay, and since all the flip-flops are clocked simultaneously, then J of this purple flip-flop will transfer to the Q of purple flip-flop, and J of the red flip-flop will transfer the Q of this red flip-flop, and like this. Okay, so what will happen? See, first pulse has come, so the J which was 0 of yellow flip-flop has been transferred to the Q of yellow flip-flop, now which is the input of this purple flip-flop right now, and the CD has turned, and now new bit is 1. Initially it was 0, CD has turned, new bit is 1, so now bit 1 is presented at the J of yellow flip-flop. Okay, now what will happen? In case the second clock will come, then 1 of the J of yellow flip-flop will go to the Q of yellow flip-flop. Now this 0 will go to the Q of purple flip-flop. Again for red flip-flop also, this 0 will go here and this 0 will go here. Okay, so this is the second clock. Now the third bit in the CD, initially it was 1, now it is 0. So this 0 is presented here. Now in case third pulse will come, then this 0 will go over here, 1 will go over here, 0 will here, and 0 will here. Okay, so this is the third pulse. Now the fourth bit you can see is 1 again, so 1 is presented at the J of yellow flip-flop. Now in case the fourth pulse will come, then this 1 will transfer here, this 0 will here, 1 will here, and 0 will here. So like this. So the code transfer 0101 took place to the shift register. So these are the 0101 is the code which has been fed to this register. Okay, now I will take a practical example to make you better that why we are doing this thing. Suppose that to the outputs of these flip-flops I am connecting a 4 input AND gate, okay, whose output is a bulb which will only glow in case all the inputs to this AND gate will be 1. Okay, so right now all the Qs of all the flip-flops are 0. Okay, you can see a NOT gate is applied at the Q of blue flip-flop as well as Q of purple flip-flop. So the code is provided to this AND gate is, since this is NOT gate, so 0 will convert into 1. So 1, this 0 will 0, this 0 will convert into 1, and 0 0. So 1 0 1 0 is provided, so this AND gate will not output 1. Okay, now in case we provide clocking, then 0 1 0 1 code in case transferred in a serial fashion like this, then 0101 is the code. Now for 0, this NOT gate will convert it into 1, 1 is 1, and 0 again convert into 1, and 1 is 1. So all are 1s. Now the bulb will glow. Okay, so this code, this CD contains the code which can glow this bulb. Now we can consider this as an input to the yellow flip-flop. Whatever bit which is going inside to the J is the input, and suppose I am taking this as output, the final Q of this blue flip-flop, this is the output. Now what is happening right now, the bit which is present at the J of yellow flip-flop is 0. Okay, now in case for this AND gate, if I turn this one, the right hand side one, to 0, in that case this AND gate will be inhibited, no data transfer will take place. Okay, after turning this one to 0, always the J of yellow flip-flop will be 0. Okay, now in case the fifth pulse will come, this 0 will go here, and this one here, this 0 here, and this 0 here. So this is the fifth pulse, you can see that has happened. Now again there is 0 at the J of yellow flip-flop. Now in case the sixth pulse will arrive, then this 0 will go here, this 0 here, this one here, and this 0 here. Okay, so sixth pulse, you can see that has happened. Now in case seventh pulse arrives, then again like that the code will shift, so ultimately output is over here. Okay, so this type of data transfer, in which in a serial fashion the data is input to the shift register, and in a serial fashion the data is coming out, is called as serial in serial out shift register. Okay, now suppose I am taking that cascade of flip-flops, okay, in which the code was 0101, means serial data transfer already took place. So the codes at the Qs of all the flip-flops are, you can see, 0101. Now these 01s are connected to cascade of another flip-flop. You can see the top cascade and the bottom cascade. So in such a fashion they are connected that the outputs of this lower cascade are connected to the J's of upper cascade in parallel fashion. You can see that Q of this yellow flip-flop is connected to J of yellow flip-flops at the top, and Q of this purple flip-flop is connected to the J of purple flip-flop at the top, and like this for red also and blue also. Now in case clock pulse is provided to this top cascade, whatever data which is present at the J of all the flip-flops, that will transfer to the Q. 1 will transfer here, 0 to here, 1 here, and 0 here. So like this, but in parallel fashion. Okay, so what we see that this bottom cascade is acting as a data is entering inside in serial fashion. 0101 entered in serial fashion, that we have already done here. Okay, so for this bottom cascade, the data transfer style is serial in, and since all the bits are connected parallelly to the top cascade, So parallel out. So this is an arrangement in which data transfer is taking place serial in parallel out. Now for the stop cascade, what is happening? The data is input in a parallel fashion, and in parallel fashion it is coming out. So the stop cascade, the data transfer fashion is parallel in parallel out. Now here we can see that there is circuit of shift register. Okay, now we can see that J's of all the flip flops are outputs of AND gates, 4 AND gates, in which one of the terminal is connected to the output of a NOT gate, and other terminal is the data input terminal, means this 0 1 0 1 is for data input. Okay, so in case the input to this NOT gate is 1, then output will be 0. In that case, no data transfer will take place, because in case any one terminal of an AND gate input is 0, output is always 0. Okay, now 1 is input to this NAND gate and 1 is input to this AND gate also for clocking purpose. Okay, now suppose the datas are 0 1 0 1. Now it becomes 0. So when it becomes 0, the NOT gate output will be 1. In that case, the data will be transferred to the J's of all the flip flops. You can see now 0 1 0 1 are presented at the J's of all the flip flops. Okay, now in case this 0 again goes back to 1, these AND gates will be inhibited. Okay, for this AND gate, one input will be 1. Okay, now in case I supply the clock pulse to this free input of this AND gate, and then clock signal will proceed, because one of the terminal is already 1. Okay, so 1 will go here, and this 0 here, this 0 here, and this 0 here. So like this. And now in case second clock pulse comes, then 1 here, 0 here, 1 here, like this. Third clock pulse, then 0 will be here, 1 will be here, and 0 will go there. Okay, so this is a case in which the data is transferring through this shift register in parallel in and serial out, because ultimate output is over here. So parallelly the data is going in, however the data transfer is taking place in serial fashion. So parallel in, serial out. Okay, so hope by this small lecture you would have understood about shift registers as well as the different type of arrangements of data transfer in case of shift register. Thank you.